My name is Akash. I'm a junior from North Carolina. I know now you guys are probably like, okay, why is the student teaching us? In the past, Fireball has always, or a main focus of Fireball has been building a community and having students, teaching students. I took AP Environmental Science last year, and I've taken AP US Government, AP Statistics, obviously AP Environmental, and AP World. If you've seen me streaming before, you've probably seen me on AP Government. This is one of my AP Environmental streams. I'm really excited about Fireball, all the opportunities it provides. I've been doing Fireball since August, so it's a really great platform. So if you guys are just joining us during this interesting quarantine vacation, Fireball is a really good platform for you to get ready for the AP exam. All right, so let's get started. So the three objectives directly from College Board that we're going to be covering in this stream are 6.3, which is fuel types and uses, 6.4, distribution of natural energy resources, and 6.5, fossil fuels. You'll find that we spend most of our time within 6.3 and 6.5. 6.4 only has like one objective, and I'll kind of discuss it later at the end, and you'll get to see a map of that distribution. So the first thing we're going to talk about is probably something basic. You guys probably already know this from your middle or elementary school years. Your sources of energy can always be either renewable or non-renewable. So if someone wants to answer in the chat, what's the difference between renewable or non-renewable? Yes, renewable can be replaced or replenished during our lifetime. It's the way we think about it. Additionally, renewable tends to have less lasting effects compared to non-renewable. When we think about non-renewable resources, those things are not going to be able to be replenished during our lifetime. So that's kind of the logic we use to compare those two. So in terms of how electricity is produced, like a general pathway for electricity to produce, your first step is that an energy source would provide power. Then that energy source would heat up the water. That becomes steam, right? It goes from liquid to gas. Then that steam turns a turbine. The turbine converts kinetic into mechanical energy. And then this causes the magnets in the generator. So if you can see that picture or diagram on the right, to pass over the wire coils, that generates a flow of electrons, and that's what creates that electricity. Okay, this current, again, is the final step in that process of electricity. So in terms of the sources of energy that can get that water to start heating up and turn to steam and so on, with non-renewable resources, and what we're going to be focusing on for most of this, you have your fossil fuels. So that includes oil, coal, and natural gas. Nuclear power is normally also classified under that non-renewable resource category. Then with renewable resources, you have hydroelectric, solar, biomass, wind, geothermal. Any of those can be classified under renewable resources. Okay, so the next thing we're going to talk about, where do we get the energy to heat up the water from that first step? So I just gave you a big list of examples. So what do you think is the primary source in the United States or even in the world to heat up that water, to get you that first energy source? Yes, oil. Anything else? Fossil fuels? Nuclear energy? Yes, so all of those things can be a part of this. Okay, so fossil fuels in the world or global energy sources, fossil fuels makes up about 64%. Renewable energy is 19%, and then nuclear energy is 17%. Obviously, just kind of know that these are not like, hard numbers. Like, it's not exactly 64% probably. However, you will never be asked to recall exactly what percent you get. Nuclear energy gets its own category. I just kind of it's not fossil fuels. It is a part of non-renewable energy sources. However, it's not really a fossil fuel. So that's why I put it under its own category, because it's not a renewable energy and it's not fossil fuels. If we had it as just renewable and non-renewable, your 64 and 17 would combine together for that. A good question. Okay, so with fossil fuels, you have oil. So oil is basically just long chains of hydrocarbons. If you don't know what a hydrocarbon is or haven't taken chemistry, it's basically that chemical formula that I have right there, CXHY. Sometimes you have an oxygen attached there. It's carbon and hydrogen, okay, just kind of what the name sounds like. With coal, that's a mixture of carbon, hydrogen, oxygen, and other atoms. Then natural gas is mostly CH4, which is methane gas, with a mixture of other gases. So some examples are like pentane or butane in small quantities, okay? So those are the three main fossil fuels that we're going to be discussing because those are the main three that are emphasized within the College Board curriculum. Okay, so in terms of fossil fuels, what are fossil fuels, right? So fossil fuels are formed from the fossilized remains of once living organisms. So that's like your definition for fossil fuels. And over long periods of time, organic matter is exposed to lots of heat and pressure, right? Just because of the way nature is set up and the way the world works, it's going to be exposed to heat and pressure throughout its lifetime, you could say. Eventually, those forces are going to break down into organic molecules. And those organic molecules break down into oil, coal, and natural gas. Okay, so one thing that I want to discuss in terms of the sources of these, I'm going to give you a few specifics that I'm not going to really go into in as much depth with the next few slides, but I do want to emphasize that in my with the notes that I've written down for this slide. With oil and natural gas, your main source is going to be ancient marine organisms like zooplankton. Then with coal, you have organisms in ancient swamps like plants, as well as anaerobic bacteria that are found in those areas like landfills, swamps, etc. Okay, in terms of the combustion of fossil fuels, it's a normal combustion reaction. So it's your fuel plus oxygen, and that yields carbon dioxide and water. Eventually, this releases energy. Okay, so in combustion, don't you need hydrocarbons? Yes. So your fuel is where that hydrocarbon is going to be. So remember how we talked about with the oil and the coal, both of those involved carbon, hydrogen. Yeah. So your fuel is where you get that hydrocarbon from. So the next thing we're going to talk about is fossil fuel reserves. So we know all about what fossil fuels are, but you need to get them from somewhere, right? So where are they found? The first kind of step with this is that geologists use their knowledge of rock formations, of the landscape, etc., to predict where those fossil fuel deposits might be found. We'll discuss later with that 6.4 standard about the distribution of energy resources. In the Middle East, you'll find a lot of oil, right? So it's more likely that those geologists and people there are going to be looking for those oil reserves. So based on the formations, rock formations and stuff that is in that area, these geologists predict where they might be found, and they supervise the extraction of these resources, right? So the first step that kind of happens are these exploratory drills, okay? So the drill is used to test the site and kind of estimate how much of a fossil fuel is there, okay? Eventually, when they hit a reserve, they find for sure that there's something there. That's called a proven reserve, okay? And that's when the geologist is basically certain that there's a reserve there. So there's an energy resource there. Your next kind of step in this is how much of the resource are we going to be able to obtain, and how much does it cost? So the amount of resource that you can actually extract from there realistically depends on the amount of technology you have, as well as the cost of extraction. So let's say it's the resource is like further deep in the ground, deeper in the ground. The cost of extraction is probably going to be a little bit higher. So it's not economically feasible all the time for you to extract that, especially if it's just a small amount. So the resource that's extracted, it kind of has to balance the value of the fossil fuel. So if it's really expensive, they're doing it. It's likely because there's a lot of that thing in the reserve. Okay, so you just kind of have to do like a cost benefit analysis, kind of something that you would learn in like a personal finance class almost. You kind of have to do that just when you're looking for those fossil fuels. Okay. So the next kind of specific fossil fuel that we're going to talk about is crude oil. Okay, so crude oil, what that is, it's basically a raw or fresh oil when it's pumped up from that reserve. Okay, the crude oil and the way it's structured, or its structure, depends on the reserve that it comes from. So it could be really thin, really viscous. It just kind of depends. Additionally, it could have a range of like sulfur content. That's a big thing with crude oil. It can vary in color and stuff like that too. Does anyone know like particular uses for crude oil, where crude oil could be used in terms of production other than fuel, petroleum? So that's like with the production of fuel products, right? Also the production of plastics, petroleum jelly, like you said, all of those things have to do with crude oil, okay? So there's three different methods for extracting oil. So your first method is going to be primary extraction. Primary extraction is basically when you tap the oil well and the oil is just pumped to the surface. So that's kind of your most basic one, and it's the easiest way to extract that oil. The next type is pressure extraction. Okay, so pressure extraction is when the oil is harder to extract. Basically, some methods that could be used here include like mud, salt water, carbon dioxide, all of these things could be like basically like pumped in to push that oil back out. Okay, so from the reserve. So yeah, primary, that's the easiest. Pressure is kind of next. Then you have heat extraction. So heat extraction is kind of just the way it sounds. And it's basically you have steam, hot water, hot gases, anything like that. They're used to kind of melt the crude oil, especially if it's really thick or viscous. And then that makes the oil easier to extract. Okay. So these are the three main methods that you need to be aware of for your AP exam. One thing that I also want to kind of a side note here is that obviously we don't know what the FRQ is going to be on the AP exam. I kind of mentioned this earlier. Could be a FRQ where it's just one, or it could be like 3 or 4. We don't know what College Board is expecting at this point. I would still make sure you're preparing for everything in units 1 through 7. So commonly a FRQ that I believe AP emphasized was like the designing an experiment. I know they have math FRQs this year. I think you guys are allowed to use a calculator, if I'm not mistaken, on your math FRQ. I think this is the first year they're letting you do that. So again, we're not really sure how they're going to do it this year. So just kind of be prepared for whatever that entails, okay? The next thing we're going to talk about with crude oil is its damage to the environment. So it has moderate damage to the environment. However, not much land is needed to drill. Really, that's where most of that environmental damage in terms of the land comes from. However, you also have environmental damage in terms of the transport. So it's going to have to be transported by a tanker, by cars, or not by cars, by like trucks or pipelines. All of those things can create environmental hazards. This is an easy negative. I know on past AP environmental FRQs, one thing that they would normally do if it was like an energy FRQ is that they'd be like state 1 advantage or 2 advantages, state 1 or 2 disadvantages. Normally, with like the advantages, easy ones are like creation of jobs or something like that. With disadvantages, it could be this like transport method. So like whenever anything, right? So when the pipe bursts, oil spills out, that can have an effect on wildlife, right? All of those things can be easy negatives that you can use if they ask you to present a disadvantage. Okay. So does anyone have any questions so far in terms of the content we've covered? Hopefully this stream should be pretty short. So yeah, if you have any questions, just let me know. Okay. So the next thing that I'm going to talk about is coal. So what do you guys already know about coal? It's burned. Good job. Anything else? Okay. So yes, it's dirty to burn. So it does cause a lot of air pollution. Yes. So what we're going to talk about specifically with coal, first off, is like the quality of coal. So if you guys have an AP science or environmental science review book, you've probably seen like a little chart on there with the qualities of the different types of coal. Basically, it's ranked based on the amount of energy it produces when it's burned. Okay, so anthracite is going to be your purest coal. That's like pure carbon. Next is bituminous. That's your second purest. And then lignite is your least pure coal. So purest is going to produce your most energy. Lignite is your least pure coal. That's going to produce the least energy. Okay. In terms of coal mining, this is probably something more apt for an FRQ. Coal mining can be hazardous and have extreme environmental impact. So you have the 2 main ones that we're going to focus on here. Obviously, there are more. Are strip mining and underground mining. So with strip mining, what you have is it's a removal of like literally the Earth's surface, and they go all the way down to the level of wherever the coal is, and that's how they get that coal. Okay. So does anyone know what that removed Earth is called? So we said it's strip mining involves removal of the Earth's surface, but there's a term for that remove or what's being removed, the part that you removed from the Earth's surface. Does anyone know what that term is? All right, so that term is overburden. Okay, so if you see, that's okay. If you see overburden anywhere on your AP exam, just know that it has to do with that actual part of the Earth's surface that was removed during that mining process. Okay, when that coal is removed, the overburden is replaced and topped with soil. So that's kind of the way they replenish that, and then the area is contoured and revegetated. Okay. So a major con for this is that it leaves behind a slag which is basically amount of waste that comes as a result of this coal mining. It's hazardous. Additionally, one thing that is present within these slags is sulfur. So sulfur can leach out, and this can cause major environmental impacts on wildlife. So again, this is also an easy way for you to present a disadvantage, okay? So let's move on to underground mining. Okay, so again, both of them can be hazardous with an environmental impact. With underground mining, that involves sinking shafts to reach underground deposits. Basically, what happens is that networks of tunnels are dug and blasted or blasted, and then humans enter those tunnels to manually retrieve that coal. So they literally go in so that they can get that coal. The major con with this is that after the production stops here, cave-ins can occur, and that can cause subsidence or massive slumping and subsidence. Okay. In terms of what coal is used for, it is used to generate electricity in 30% of power plants in the United States. So this is like a huge part of our energy. Okay. So the next thing we're going to talk about is burning coal. So does anyone want to share anything or know anything about the air pollution effects for burning coal? Okay, so yes, good job. So with burning coal, several parts of the negative effects include air pollution, okay? So nitrogen oxides, sulfur dioxide, those can all be released during combustion. Additionally, some of this stuff can be removed through something that's called scrubbers, okay? So in terms of burning coal, we know that it produces these bad things, right? Bad air pollutants. Additionally, it can also produce something that we're going to talk about probably later on this slide called fly ash, which is basically just like flecks of dark stuff that's carried into the air, so air pollution, and then boiler residue, which is like the bad, ugly stuff that's left on the bottom of a boiler, and that's also going into the air. In terms of scrubbers, you have a few different types. The main one that I'm going to focus on here is just a general one, okay? So basically it contains an alkaline substance and it precipitates out the sulfur dioxide. And then, like I said, that fly ash and boiler residue may be able to be eliminated by some of these scrubbers. One scrubber that I want to highlight is a wet scrubber. It uses a fine mist of water basically to transform that sulfur dioxide or any SOx basically from an air pollution issue to either a water pollution issue or like sulfuric acid, some kind of commercial product. So, I mean, I guess it's not air pollution, but then it's water pollution. There's all these different types of things that people have created in order to mitigate the air pollution effects, okay? So, let's go to the next part, burning coal. So, coal power plants can be a source of mercury pollution, okay? So this is really important. And this is something that could easily be asked on the AP exam because it also tests another skill in terms of biomagnification. So with coal-fired power plants, basically airborne mercury can go hundreds of miles. And what happens is it accumulates in water. Therefore, the fish are in the water, they get it into their system, and then biomagnification happens. Does anyone know what biomagnification is or want to explain it? Yes, gets eaten and spreads, and specifically it goes up the food chain, right? So humans eat fish and then they get it into their system. So when the mercury contaminates these bodies of water, basically it's also impacting us. It impacts humans. Okay, another effect of abandoned coal mines is acid mine drainage. It's highly acidic water, basically flows to the surrounding areas, okay? So the next thing that I want to talk about is natural gas. So does anyone know anything already about natural gas? Yep, gas stoves. Basically, it's stuff that we use every day, probably. Okay, so many of its uses include heating homes, cooking, basically burn to generate electricity. The pros of this is that it's a lot cleaner than most of the other ones we talked about, especially coal. It only produces carbon dioxide and water when it burns. However, it does have some negative effects. So in terms of leaking, it can cause violent explosions. Yes, it is flammable, and it's difficult to transport. So what happens is they liquefy it because it can't necessarily be transported as a gas all the time, since the tank can probably only hold a small amount of that gas. And the gas is put under high pressure to liquefy. Okay. Eventually, the pipe transport can also lead to leaks and explosions. And if it explodes, there can be habitat damage due to the building of those pipes or the explosions. Okay, so that's all I have for natural gas. All right, so the next thing I'm going to talk about is fracking. Okay, so fracking is hydraulic fracturing, and it's basically a process where natural gas or oil is extracted from the ground or from deeper under the ground rocks. Okay, basically the process and the way it works is that a deep well is drilled, and this fracking fluid is injected at a really high pressure. When this happens, the rock is literally fractured, and then it releases that oil or gas. Okay, so that's one method. Controversial method in which we obtain natural gas or oil. Some major effects and negative effects for this is that it's been linked to earthquakes in Ohio, Pennsylvania, Arkansas. Specifically, what College Board wants you to know is that it can cause groundwater contamination, and it leads to the release of volatile organic compounds. Okay, so these are like organic chemicals that have a high vapor pressure at like your normal room temperature. An example of like not necessarily something that fracking can cause, but like chlorofluorocarbons, CFCs. That's an example of a VOC. If you need like context. Okay, so a few other things. So kind of like rounding out what we talked about with 6.3. Wood is something that's used in many developing or slowly developing countries as fuel for firewood and charcoal, just because it's so easily accessible. Okay, that's one of the main reasons why it's used. Additionally, you have natural gas. Natural gas, like we talked about already, is the cleanest to fossil fuels, and it's mostly made of methane. Then you have crude oil, which is a combination of clay, sand, water, and bitumen, which is basically asphalt. And then you also have this term that College Board emphasizes, which is cogeneration. Cogeneration is just that a fuel source is generating a useful or basically two things: useful heat and electricity. So since both of those are happening at the same time, it's like so like co is like working together, cogeneration. So that's basically how that term works. Okay, college. This slide really is what College Board has outlined in their AP course and exam description. So if this standard ends up being on the AP exam, this is something that would likely be tested. Okay, so like I promised at the end, we were going to talk about standard 6.4, which is really tiny, but it is pretty important. Okay, so global distribution is not uniform in terms of natural energy sources, and it depends on the geological history and what's present in that area. Now, with a growing population, you can kind of assume there's a direct relationship between population and the consumption of resources. The more populated a country is, the more resources they're going to consume. That's what you would think, right? Generally, it tends to work out that way. However, most consumption actually occurs in industrialized nations. So China, India are the most populated countries in the world. However, they use a fraction of the energy resources we do because the United States is significantly more industrialized. Okay, so that's kind of something that you'll see as a common pattern. Russia has the most natural gas. These are just kind of like facts, something that you would probably be familiar with in terms of oil. Probably seen this really in politics, is that 67% of crude oil reserves lie in the Middle East. Additionally, the United States possesses more coal than any other country. So that's also something important that you should be familiar with. So the United States would go with coal, oil would go with the Middle East, and natural gas would go with Russia. Okay. If you look at the map, hopefully you guys can somewhat make that out. That kind of shows where all of your major reserves are. Obviously, you can see the United States has the coal. All of these red dots, those are all, all of those red dots, those are your oil reserves, your crude oil reserves. And then finally, the blue triangles is where your natural gas is going to be. And obviously, you can see right there up here is that's in Russia, right? So that's where your natural gas reserves are. The United States is kind of what I was talking about with the industrialization thing. The United States has 4.5% of the population, but uses 20% of the world's energy. So you can kind of see there's an obvious disparity there. That's just kind of almost the truth of it, is that even countries that are much less industrialized, they don't tend to use as much energy as we do. being an industrialized country in the United States. Okay, so that's all that I have in terms of content.